In this lecture, I'd like to make a few comments about question 2a in your guided practice 8. So this was the question. It was for all a, b, c, and p of u, if a is a subset of b, then a minus c is a subset of b minus c. As is the case for every other proof you're going to do, you always want to read from left to right, writing the appropriate statement as you go. So this is what you see first, and so you should begin by saying, let a, b, and c be. You could either say elements of the power set of U, but that's a little bit awkward, and it's better to say what that really means. To say something is in the power set of U is to say that it's a subset of U. So it's better to say, let a, b, and c be subsets of U. And now we come to the conditional part of the statement, and assuming we're doing a direct proof, you should assume your hypothesis. You should say, suppose A is a subset of B. Now, once you've assumed your hypothesis, the next thing to try to do is to prove that the conclusion is true. And so you should next try to prove that A minus C is a subset of B minus C. So how do you prove something like that? Well, you write down the working definition of this statement, and the working definition of it is this. So you're next going to try to insert a proof that this is true, which means you're going to write a proof of this. So how do you write a proof of something that looks like that? Well, you read it from left to right, and as you go, you write the appropriate thing. So you first begin by saying, let x be in U, suppose x is in A minus C, and then you try to deduce that x is in B minus C. And in trying to deduce that x is in B minus C, that's when you're going to make use of your hypothesis that A is a subset of B. But you needn't say anything about A being a subset of B or what that means until you need to make use of it. So in other words, a lot of students at this point in the proof here, instead of doing what they should have done, namely take an x in A minus C, they wrote let x be in A. And there's no reason to do that because you're not trying to prove that A is a subset of B. You're trying to prove that A minus C is a subset of B minus C. Okay, so let's go over it one more time. We start by giving ourselves three sets A, B, and C, subsets of U. We assume that A is a subset of B, and then we try to directly prove that A minus C is a subset of B minus C by carrying this program out here. Okay, so put your video on pause and see if you can write up the proof correctly this time. And when you come back, we can compare our answers. So here's my proof. Reading from left to right, I say, let A, B, and C be subsets of U. Suppose A is a subset of B. And then I'm going to, next I write, just to warn the reader, we now show that A minus C is a subset of B minus C. So how do I do that? I take an x in here. So let x be in the universe. Suppose x is in A minus C. Now I write down what that means. That means x is in A and x is not in C. Now I make use of the hypothesis. Since A is a subset of B, it follows from the fact that x is in A that x is in B. Since in addition x is not in C, as we assumed here, it follows that x is in B minus C by definition of set theoretic difference. So finally I have the right to say that A minus C is a subset of B minus C because I started off by giving myself a generic x in A minus C, and I proved that it was in B minus C. This completes the proof. It's just a few lines long. I've had people turn in 2 pages in order to get the proof of this. I've said everything that needs to be said in these 5 short lines. I haven't left out a single detail, but yet the proof is all there, and that's all that needs to be said. The big mistake that students were making was when they got to this point here, they said let x be in A. There's no reason to do that. You're not trying to prove that A is a subset of B. You already know it. You're already assuming it. This is the key step here.